In today's lesson, we are going to see what is multiprocessing and what is multithreading. Before we talk about multiprocessing and multithreading, let's talk a bit about multitasking. What is this multitasking? Let's talk about multitasking with a real world scenario. Take a man who is watching a cricket match while drinking a cup of coffee, and at the same time he is also answering his mobile phone. So this man is doing multiple operations, multiple works on the same time. So this is what basically we call as multitasking, doing multiple tasks on the same time. In computer science, this same theory can be applicable in many ways. So in this webinar, we are going to see about multiprocessing and multithreading, which are some forms of these multitasking concept in computer science. So in this video, we are going to see what these concepts are and how they differ from each other. And at the end, we are going to do a live demonstration with using a programming language on how we can implement multiprocessing and multithreading in programmatical way. So I recommend if you are going through this live demonstration, you should have at least a basic knowledge about programming. So if you're having some understanding about Java language, it will be an added advantage because I will be writing this program using Java. Okay, let's move on. Before we see about multiprocessing and multithreading, first let's see what is a process and what is thread means. So process is a program. So this will be having multiple threads inside it. It's basically an independently running program in a computer. Okay, so for example, let me show you practically. So here in my window, you can see I'm running multiple programs, multiple applications actually. So here it's PowerPoint, and here I am having an IDE, and here the web browser, Zoom, and File Explorer. So if you go to the Windows Task Manager, you would see these processes that are running. The process means they are programs. So each of these process will be having a unique process ID. So here you can see every process having a ID. So how these processes are getting executed in the CPU is a different area. So there are concepts like CPU scheduling algorithms, dispatchers, ready queues, context switching. Likewise, there are so many concepts going behind this. So we are not going to talk those things in this video. I just want to show like what are the processes and how they are running. So this is what are the processes. Actually, the process means it's the program that we are running. So they will be having a unique process ID get assigned that will be executed by the CPU. This basically the process means. Let me go back to my presentation. So actually thread means it's the single unit of a running process or a running program. Actually this thread comes inside a process. So each process will be having certain set of memory spaces and resources that are allocated to that particular program. So different processes will be having different resources that it uses. But if you take a thread, a single multiple threads may share the same memory space that was used by the process. Like let's say this is T1 accessing the thread 1 is accessing inside this process, and it's accessing the memory space of this process. And there's another thread called T2. It is also accessing the same memory space. T3 also accessing the same memory space and the resources of process 1. So the process is like the big boundary. So threads falls inside this particular process. So that what's the difference between the process and a thread. So as you can see here, two different process means these are two different programs that are running independently. Process 1 means it's a different program, it's a different application. Process 2 means it's another different application. So these doesn't share each other's memory space or resources unless we have some shared memory which is available, which exists in externally, and we can share a file system likewise. And it is really complex to communicate between these two processes because they are totally different programs that are running in different languages. Maybe the process 1 is running using Java, and process 2 is Python, and there's another process running in C#. Likewise, those are different technologies. So communicating, in the sense, there are various ways that we can use, like WebSockets, communication protocols like TCP or API calls, and there are a lot more things like gateways, outbound and inbound gateways. So those are not simple ways to communicate. Those are really complex implementations. So we will see a comparison between like about these processes and threads in coming slides. In this slide, you can see a high-level comparison between multiprocessing and multithreading. So previously we spoke about processors and threading. So having multiple processes is what we call as multiprocessing. So there will be multiple programs running. In multithreading means it's multiple threads are running inside one particular program. That's the basic idea. So if you take this multiprocessing, it's a heavyweight because it comes with a complete program, entire program. So it's having a larger memory space, multiple resources that comes under each process, and it running in on its own process ID in the operating system. As I mentioned, like multithreading, smallest unit of a program or a process, so it's really lightweight. In multiprocessing, every program has its own memory space, as I showed before. So each process will have its own memory space. They won't collide each other. But if you take threads, they share the memory space of the process to do multiple operations. So one thread might be doing certain operations on this memory space, and the thread 2 might be doing a different operation, and thread 3 might doing some other operations. Likewise, on the same under the same program, these threads might be performing different tasks. So we saw this. So multiprocessing means it's a running program, and multithreading is isolated unit of a single program. Inter-process communication is expensive, as I mentioned here. So there are a lot of communication methods that we have to use, like outbound gateways, inbound gateways, WebSockets, TCP communication. Likewise, because each process differs by their implemented technologies and programming languages. So it's really expensive tasks. Where in this multithreading, the intercommunication is not expensive because each and every thread resides inside one single program. Finally, we have this context switching. I think I have already mentioned about context switching. It comes under this CPU scheduling kind of concepts. So context switching is in basic understanding is like switching between the processes. So that means when one process completes, switching to the another process, or maybe, I mean, it depends on the scheduling algorithm that was used by the operating system. Sometimes before the process completes its execution, there's another process might get executed. So the way it happens is a different area, as I mentioned before, which I'm not going to talk in this video. So that switching between the process is complex in here because it has to switch the entire program in the CPU. So behind the scene, it's a complex operation. Where in this threading, we can simply do this context switching because every thread comes inside a single process. So switching between these threads are not that complex since they share the memory resources. Okay, that's the high level understanding about multiprocessing and multithreading. Now let's do a live demonstration on how these can be implemented using Java programming language. So the other programming also we can implement these concepts. These concepts are there like Python, .NET and all. So for this video, I'm going to do the implementation using Java language. So as I mentioned at the beginning, to go through this demonstration, you should have a basic understanding about doing programming. And if you have some Java knowledge, then it will be an added advantage. Even though you don't have any programming knowledge, that's okay to go through this so that you can get some high level input about how these things are getting implemented practically. To develop the demo program, I'll be using the STS IDE. So using IDE will help me to create the program quickly. So first, let me create the program for the multiprocessing. I'll be creating a new Java application. Let's name it as multiprocessing demo. Okay. Okay. Now I'm going to create a main class, which is my main program. I'll name it as multiprocessing app. So this is the main program where I'm going to create the multiprocessing. So Java provides some builder classes to create, execute external process applications or programs. So there's a process builder class which we can use to execute processes. So first I'm instantiating the process builder object. Then I need to provide what is the command that I'm going to execute. So for this sample demo, I'll be executing a simple ping command. So it's like this ping, you already know that ping commands, we can test the web host, whether the network connection is working fine, likewise. So I'm going to test hafizmarzuk.wordpress.com. So this is what I'm going to execute from my Java application. So here you can see, so when I run my Java application, there will be a Java process running because I'm using Java language. And then I'm going to execute this command in a CMD. So there will be a CMD process running. And then this ping also a separate program. So it's also separate application or a utility. So there will be a separate process for this also. So you will see 3 different processes being running when after I completing this particular demo application, and then when I execute this program. So let's see how it goes. Okay, so for this command function, you can pass a string array of commands. So I'm going to pass command exe, then I'm going to add the C option. So the C option is nothing but it will convert this string characters into a executable command. So here I am providing my ping URL at wordpress.com. Okay. Let me rename it as process builder, because using the builder, we are going to create a separate process object. Now we can create the process object. From the builder object, let's start the process. So this start will runs a new process. This process builder class is a very powerful facility that was provided in Java language. And here, when you're starting the process, there it will ask to like handle certain set of exceptions. So at the moment, I mean, you might be knowing what is this exception handling. If you have some understanding about programming languages, I'm not going to mention those things here. So at the moment, I'm just throwing these declarations here. Otherwise, I need to handle it explicitly. Right. Okay. So the process has got start. So to make sure I'm getting the output, I'm going to write this process output into the console, into a buffered reader. Let's get the buffered reader object. New buffer reader. Okay, I am reading as an input stream. This is just additional step. So here what I'm going to do is I'm after executing this process, I don't know like what's going behind. So I just want to print the output. So for that purpose only, I am using this buffer reader, and from there I'm reading the process output as a stream input stream. That's it. Right now, let's print the output to the console. While we are having a output from the buffer reader, we are going to print it. That's it. Okay. So this is our multiprocessing application. So what it does is, from the process being builder, it's another process. We want to execute this particular command, ping command, through the CMD terminal command prompt. And after starting the new process, I'm getting the output as a buffered read object, and then I'm printing the output in the console. Right. So I can directly run through STS itself, but in that case, it will be difficult for me to show the processes. Therefore, I will execute this from a separate terminal. I'm opening a command prompt. Going inside the directory. First, you need to compile the program. Okay, there's a spelling mistake. Let's rename it as multiprocessing. Multiprocessing app. Okay, it will be easy to identify. Let's compile this application. So whoever having some basic understanding about Java, they know what is this compiling means. So we are converting this Java app program into a machine readable bytecode. So that's what's happening in this Java C command. It will compile the file into the class file. So from there you can run the application. Before running that, let me open the task manager to show how the process is showing up. So this is the command prompt that what you can see in the right side. So you can watch this left side while I'm running this application. Okay, let's run the application. Multiprocessor app. There should be 3 processes. New process will get open up. You can see there are 3. I'll try to put a screenshot so because it's running quickly. Let me rerun. You can see 3 different processes started. Here it's printing the output. So what basically happened is when running this is the main program that I'm having. So when I'm running it, it will run under Java. So there will be a new process for the Java since it's a new program. So inside this for the new process, I am executing this command through a command prompt. So for this command prompt, there will be a new process will get open up because it's a new program. And if you take this ping command, it's a different program. Even though we are running it inside the command prompt, this ping is a separate application, separate software utility. So for that also, there's a separate TCP/IP process will get open up. So altogether, there will be 3 new processes are getting open. So they will be having unique IDs also assigned. And that's how this multiprocessing works in Java. And yeah, now let's see a demo about multithreading. For the multithreading app, also I'm creating a new Java project. Let's name the project as multithreading demo. And I will be creating a main class file. Let's name it as multithreading app. Inside that, I'll be having the main method. So under the main method, we are executing this particular application, right? So here basically what I'm going to do is inside a single, so what's the thread means? Inside a single program, you will be having multiple threads. So for a single program to function, you can segregate different operations to run under different threads. That's what I'm going to do in here. So here, what's my logic is, I'll be having a text file, txt file, where there will be some marks, like let's say it's student marks. So in one thread, these marks will be just displayed on the console. And from another thread, I'm going to calculate the total. That's what I'm going to do. So first, let me create that text file. Marks.txt. Let me add some marks in there. Okay, right. Now let me create the threads for this application. So there are 2 different ways of creating threads in Java. One is you can implement a runnable interface, and the other one is extending the thread class. So if you are familiar with programming, you might be knowing what are classes and what are inheritance and what are the meaning of interfaces. So I'm not going to discuss those things in here. So let's create the thread classes. First, I'll name my first one as thread 1. Okay, so in here, what the method I'm going to follow is I'm going to use the inheritance. So we can extend the thread class from Java. So this is a Java class that they have provided for us to create threads. So in Java, under thread, we have two overriding methods. One is called start and one is called run. So start is the function which we are going to call from our main method. So once you call the start function, so there will be another function called run that was provided by this thread class that is getting executed. And in our custom thread, we are going to override the run function, run method that was given to us by this thread class. So all our business logic will go under this particular run method. Let's see. Okay, now, okay, let me keep this like this, and I'm going to create my thread 2 as well. Thread 2 class, and this also I'm going to extend from thread. Okay, so as I mentioned, what this first thread will do is it will just read this marks text and print all the display these marks in the console. And the second thread is read these marks and calculate the total value. That's what's basically going to happen. Okay, now let's write the code for that. First, I need to read the file. For that, I'm using the file scanner. Okay, added the file object, and I'm using the scanner class here because it's a bit convenient, because it will validate the data types, primitive types, those things. So there's an additional advantage of using scanner. Otherwise, there are some other ways you can read a file in Java. Okay. While the scanner has lines, I'm going to print the marks. Right. So this is what it going to do. So here you need to handle the exception. Let's do that. Okay. 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 So since when you open the scanner, you need to close it. Otherwise, there will be like memory issues kind of things. So let's add a final block here and close this scan object. Okay, so our first thread is done. Here I am creating a file object for this particular marks text file, and I am scanning through the file and validating the values. And until while the marks txt file having not empty lines, I am printing it on the command prompt. Okay, that's all I'm going to do here. So for the thread 2, I'm going to do the kind of the same thing, but I'm going to calculate the total. For that, I'm initiating a total integer value, and I am calculating the total. Since this next line, it will be a string type, you need to pass it to integer. Okay. Finally, let's print this total value. Right. Okay. So we are done with our thread classes. Now let's call those thread inside this our main program. So as I mentioned a couple of times, these threads are running inside a single program, not like the multiprocessing. I'm creating a instantiating an object for the thread 1 class, and then I'm calling the start method. So as I mentioned before, this is a overriding method from the thread class. So once I call this start method, it will execute our run method. That's how the thread works in Java. Meanwhile, let me run the instantiate the thread 2 also. T2. Now start in the T2 as well. Okay, now our multi-threaded application is ready to run. It's the same way I did before. I'll be running this in the console, so command prompt, so that will be easy for me to show through the task manager. Multi-threading demo. Okay, let's compile this first. Multi-threading app. Okay, we have received the class files, the bytecodes. Right, now let's run our application. So this command, the processors for this command prompts is showing here. So watch this particular process under this group. You will see another single process for the Java program. Only one process will get added. Okay, so since this is running pretty fast, we are not able to catch the process. As a solution, let me add a sleep to this, so that will help us to monitor this new process. Should be finally. I'm going to declare this on the top. Right. Let me add the sleep method. So what it does is it will hold the thread for this milliseconds. So this milliseconds means it's 4,000 milliseconds. That means 4 seconds. I'm going to do the same thing for the thread 2 also. So it will ask me to handle exceptions. Yeah, at the moment I'm just throwing in my main method. Right. So we are ready with the multi-threaded application. Let me explain it again. So we are having this main program, which is the main process. So when I run this application, this is going to run as a Java program. So there will be a process created for the Java. So inside that, I'm having two threads doing different operations. So there won't be new process created for these threads because they are running under same program, single program. So these threads can share whatever the resources used by this application. So as you can see here, I am using this both threads are using this particular resource of the this multi-threading demo project. That's why it called as lightweight. Okay, now let me recompile and run. Recompiled. Okay, let's monitor the task manager. Yeah, you see the new process, which is the Java process. There won't be any other process for the separate threads, right? So here you can see the output. Okay. Why the output is like this? Let me explain. So in the first output, actually, it should be like mark one is these separately, right? And total marks is a different thread. But here the output is jumbled because these both threads are running at the same time because it's multitasking. That's why the output is like that. So there are many other concepts in Java like concurrency framework, cyclic barriers, thread factory to handle these concurrency and parallelism. So those are some additional theories and concepts that you can do some research. Just for additional knowledge, I mentioned those. The concurrency framework is a powerful framework that Java is having to handle these kind of scenarios. And yeah, those are the things I want to cover in this video today. I hope you had some understanding about the multi-threading and multi-processing, basically the multitasking in computer science. Thank you.